Hey guys, welcome to my kitchen. We're going to do negative exponents. So I'm going to show you very quickly some things you already know. You know 2 to the third is 8. 2 times 2 times 2. 2 squared is 4. 2 to the first is 2. And if you look at the pattern that happens, it divides by 2 every single time. So if I keep going with the same pattern and keep going down by one exponent, 2 to the 0 must equal whatever 2 divided by 2 is, which would be 1. Everything to the 0 power equals 1. I'm going to keep going with the pattern, so I'm going to go down one more exponent from 0, which would be 2 to the negative 1. And if I take that 1 answer here and divide it by 2, well, that's 1/2. If I go one more exponent down, 1/2 divided by 1/2 is 1/4. This might start looking familiar to some of you. If you look at 2 squared over here and compare it to 2 to the negative 2, you notice it's just a reciprocal, 4 and 1/4. If you look at 2 to the first, it's 2. And if you look at 2 to the negative first, it's 1/2. So here's what I want you guys to write. Now, what I'm writing on, by the way, is the back of this paper that we took notes on Tuesday. If you don't have it at home, it's no big deal. I did put a copy of it on the bundle, so if you wanted to print it off right now, go ahead and pause the video and print it off. If you don't want to, you just want to take notes on your own paper, that's fine, but take notes on something so you have some examples to look at. I'm gonna, oopsie, sorry. I'm gonna first write this out algebraically. So if I have any number to an exponent, start over. Any number to a negative exponent is equal to 1 over the same number to a positive exponent. So a couple quick examples. Since 5 squared equals 25, 5 to the negative 2 equals 1 over 5 squared equals 1 over 25. So if I have a negative exponent, it doesn't make it a negative number, it just makes it a fraction, makes it a small number. Just like scientific notation, those negative exponents just make the decimal point go back and make it a really, really small decimal, which is the same thing as a fraction. Okay? So I'm going to go through some of these examples and try to be kind of quick so you don't have to watch a big long video. Starting with 4 to the negative 2. Over 16. And if you want to pause at any time and try some of these on your own, go for it. I'm just going to kind of go through them quickly. The next one, since it's already in a fraction, here's what I want you guys to start thinking about. Everything's a fraction. If it's in the denominator and it has a negative exponent, it is not happy. So put it in the numerator and it becomes a positive exponent. So 2 to the negative 5 wants to move up and become 2 to the 5th. What's left in the denominator is just a 1. I'm writing it there, but you don't need to. It's not necessary. And then you can simplify from there. 2 to the 5th, so 2 times itself 5 times equals 32. Next one, you got a 4 on top, 4 to the negative 2 on the bottom. Well, the 4 on top's happy. He's got a positive 1 exponent on him. So I'm going to leave him where he is. And I'm going to take that 4 to the negative 2, since it's in the bottom, it's not happy. I'm going to move him up. And he's going to become right next to the 4 to the first, and we're going to multiply those together. And that's just 4 times 16, which is 64. Okay, next one, they're both unhappy. 2 to the negative 4 wants to come up here and become 2 to the positive 4. 2 to the negative 1 wants to move down and become 2 to the positive 1. So anytime you move it, the exponent changes the sign. 2 to the 4th equals 16. 2 to the 1st equals 2. 16 divided by 2. Next one, again, they're both unhappy. So 9's going to move down. 3's going to move up. Simplify. 9 is happy where it is in the numerator. 2 wants to move up. So it's going to become 9 times 2 to the 1st. And again, that's all over 1. So it's just going to be a numerator, and that's it. And that's just 18. Okay, next one. I'm going to make it look like a fraction. By the way, this is a helpful hint if you that helps you look at it better. If it's not a fraction already, make it one. Put it over 1. The negative 6 does not have a negative exponent. It's a negative 6, but it's to the positive 1 power, so I'm going to keep it there. The 3 has a negative exponent. That one needs to move. So we're going to have negative 6 in the numerator. We're going to have 3 to the positive 2 in the denominator, and simplify. And reduce. Always reduce, right? Next one, everything to the 0 power always equals 1. In fact, I'm going to go back up here and make a note. So a to the 0 equals 1. A stands for anything. Any number to the 0 power equals 1. Alright, so back down. Now we're going to do some with variables, which is okay because it just means we don't have to multiply a whole lot of numbers. So x to the negative 8. Right now it's a numerator. Move it down. Becomes x to the positive 8. Leaves a 1 up in the numerator. Next one. Look at those as two separate things. That's an x times a y to the negative 3. The x has a 1, has a positive 1 exponent on it. Leave it where it is. So if this were in a fraction, x stays up in the numerator, y moves down and becomes positive 3. That's all we can do with it. It's simplified. Do you see the difference between the one we just did and the next one? Since there are parentheses around the x and the y, that means that negative 3 attaches to both of them. So there's the difference. Now they both need to move down. So if we've got everything over 1, there we go. Okay. A is not happy, B is happy. B stays where it is, A moves down. 3 is happy where it is, W is not. 3 stays up in the numerator. The W moves up right next to it and becomes 3 to the W. I'm sorry, 3 times W to the 4th. All over 1, so I'm not even going to bother writing it because it's just the numerator. 6 stays where it is. R and S both want to move, so it's going to be similar to the last one we just did. So 6 stays there, times R to the positive 5 times S to the positive 1, which I'm not even going to bother writing. I wouldn't mark it wrong if you did. Next one. Three is not the x. 3 is multiplied with the x to the negative 6. So keep it where it is. It's happy. X and y were both unhappy, so we moved them. Again, I hope you're pausing this and thinking about some on your own. I'm just flying through them. 8's happy. B is happy. Leave them where they are. So we're going to take 8 and B and leave those up in the numerator. The A and the C are not happy. They're going to both move to the denominator, or the bottom of the bunk bed, and become a positive 3 and a positive 2 exponent. Negative 7 does not have a negative exponent, so keep it where it is. R has a positive exponent, keep it where it is. So negative 7r squared over p to the positive 5, q to the positive 3. Next one, it's already looking like a fraction and they are both unhappy. Flip it over. E to the 7th over d to the 4th. Next one. 9's happy. The n is happy. P squared's not happy, so I'm going to move them up. M is not happy, so I'm going to move it down. And last one, because I'm going to actually save the rest of it for next time. You got 4 things here, A, B, C, D. Only the C is happy. Remember, there's a 1 on it. It's not part of that negative 3 exponent. So C stays where it is. The only thing we're going to have up top is the D. And the bottom becomes C times A squared times B. And one question you might be thinking right now, especially with this one with the NP, and then this one with the C, the A, and the B, is does it matter what order I write them? No. They're all multiplied together. Commutative property says we can multiply in any order. I will say this, you'll see it when you look at a textbook or in a test or official somewhere, you'll see it in alphabetical order. So I'll actually take this last answer and I'm going to rewrite the bottom in alphabetical order. So A squared, B to the 1st, C. I am not picky though. It doesn't matter if you write them like that for me or not. It's the same thing. We're going to save the simplify, then evaluate. All right, I think you're ready to try some on your own. Keep these examples in front of you. Hopefully I'll see you Monday.